number 39 says a solid conducting sphere is surrounded by a thick spherical conducting shell. Assume that the total charge Q is placed at the center of the sphere. So I'm going to say the total charge Q, and it says it's a positive charge, is placed at the center of the sphere and released. After the equilibrium is reached, the inner surface of the shell will have one. Well, let me draw a picture. So this charge is placed inside of a sphere. That's the best, a perfectly drawn sphere. And it's a conducting shell. So this is conducting. And the question is, what is the charge here on the interior of the shell? It'll either be option 1, negative, option 2, 0, option 3, positive. Okay. And then it says in terms of Q, how much charge is on the interior of the sphere? And so we'll address that in a second. So if it's a positive charge, and we talk about the electric field is going to move away from that charge. But what happens to the shell?
If the electric, wait, say that part again.
And it says the inner surface of the shell.
Wait, so your conducting shell is moving away or towards Q?
Well, we got to think about it. Like, what happens to the shell? Basically, is it positive, is it negative, or is it 0?
Yeah, but what's Q doing?
Well, it's going to be negative, and the reason it's going to be negative is that this is due to induction. Okay?
Really, the first problem you've done?
Shh, I'm recording.
Sorry.
And then it goes through and it gives us a bunch of other options. So let me reread the question so it makes a little more sense. It says a solid conducting sphere. So it says it's solid. That means that there's stuff in between, right? Like this is a solid sphere. And it says that assume that the total charge Q is placed at the center of the sphere and released. What will be after equilibrium is reached?
Oh, because if it were positive, then it would like move it further away.
Well, what they're saying is if you put a positive charge, what's going to happen? What after equilibrium is reached? Now, equilibrium means that
It's like evenly dispersed.
yeah. So what's going to happen to the inner surface of the shell? That means that if there's some sort of induction, there should be an accumulation of negative charges, right, to reach a state of equilibrium. Otherwise, we'd have an overall positive charge. And the only way you could do that is through induction, right? And so that's what they're saying. So it would be negative due to induction. And then there's a series of questions they ask. In terms of Q, how much charge is on the interior sphere? So for part B, they want to know is how much is the charge in terms of Q. Well, it should be 0, right? Since all excess charge resides on the surface of the conductor and it's at electrostatic equilibrium. Well, equilibrium means that there is an equal number of positive charges and negative charges, so the net charge should be 0. Then part C of the question says, what about the surface of the sphere? Well, the surface of the sphere, it should be a positive Q, because that's what those negative charges, that equal amount of negative charges was sucked into the inner shell, so that should have a remaining of a positive Q. Does that make sense? Then part D says the inner surface of the interior shell. Well, that should be a negative charge of Q. And part E says the outer surface of the shell. Well, again, that should be a positive Q, which E and C are very similar. I better reread the question to make sure I'm saying it properly. So to recap, let me read it one more time, because this one, the question is written well, but it's poorly worded. It says the solid conducting sphere is surrounded by a thick spherical conducting shell. Assume that the total charge Q plus Q, a positive charge of capital Q, is placed at the center of the sphere and released. After equilibrium is reached, the inner surface of the shell will have either a negative, zero, or positive charge. It'll be negative due to induction. There's contact there, right? And then for part B, it says in terms of Q, how much charge is on the interior of the sphere? Well, on the interior for part B, it's zero, because all excess charge resides on the surface of the conductor in electrostatic equilibrium, right? Then part C says the surface of the sphere. Well, that should be plus Q, since all excess charge resides on the surface of the conductor in the electrostatic equilibrium. And so if that exists that way, then part D is easy to answer. The inner surface of the shell, so that should be, if it's in a state of equilibrium, it should be negative Q by induction and the conservation of charge. So it's just being moved from one place to another. And then it asks lastly on the end there, what about the outer surface of the shell? Well, then that should be a positive Q.
Yeah, because there's negative.